Welcome to Longevity Industries' presentation of the Destiny of Manufacturing podcast. I am your host, Dean Phillips, and I am so proud to be here today because, of course, I have with me the president of SME, Jim Schlusemann. Jim, welcome, sir. How are you doing?
Great.
It's great to have you here. So right off the bat, Jim, what's your big takeaway for the next 5 years?
Well, the next 5 years in manufacturing in the U.S. are going to be very exciting. Rewinding a little bit, my manufacturing career goes back many, many years, and through my career, I've been able to see consistent decline in manufacturing with things moving offshore and back parking lots turned into grass growing. And the next 5 years, what I'm seeing is some real exciting things as far as the reality of that trend turning the other way. I think a lot of that was we got a big wake up call with COVID, with supply chain, and seeing all the issues around that extended supply chain when something bad like COVID happens. So there's I'm really seeing a lot of energy around onshoring manufacturing.
Right.
I believe it's for real with all the indicators I'm seeing, because the business reasons and the business sense for it are starting to really stack up. But it's not going to be any easy road to hoe, but I think we're up to it, and we're going to see some exciting new things happening in manufacturing here in the U.S.
That's great. Yeah, I'm looking forward to it myself. I think you're right. I think there's going to be a lot of really good, positive things for manufacturing that are going to be changing over the next few years. So speaking of your background and everything, why don't you tell us a little bit about how you got involved in manufacturing and a little bit about your story?
Well, I got into manufacturing, Dean, pretty much right out of high school. When I was in high school, I was attending a program. It's actually like Skills USA today, but it was called the Vocational Industrial Clubs of America. And then my last 2 years of high school, I went to school high school half a day, and then the other half of the day I studied as an apprenticeship as a mechanic at a bowling alley. And if you ever get a chance to go in back of a bowling alley, if you're into mechanics, go back there and take a look at it. They're really interesting machines. They redefined Rube Goldberg. So I was very interested in the mechanical aspects, and believe it or not, computers have always been my liking too. And that bowling alley I was at was the first one in the United States that put in automatic scoring. It used to be just paper scoring, and they actually had printers and switches and networks and everything in place for that. So I learned about that stuff at a young age. When I graduated high school, I knocked on the door of International Harvester, Melrose Park plant. 1973, it was a time that if you could breathe, they'd hire you. The economy was really strong. And I went into the employment person and interviewed, and he asked me if I wanted to go into the factory or go into the office. And right out of high school, I didn't know the difference. I says, tell me what the difference is. And he says, well, if you go into the office, it's air conditioned, you can wear a tie, you're clean. He says, you don't make as much money. He says, if you go into the factory, he says, it's kind of a dirty environment, which manufacturing was back then. It isn't now anymore. He says, it's kind of a dirtier environment, harder work. He says, but you'll make more money. And he says, you'll learn things on that factory floor that you'll never learn anyplace else. And that intrigued me. And I took the role and went on to Factory International Harvester Construction Equipment, where I was making machining bulldozer parts that are big as probably a table your desk you're sitting at. So I was always intrigued in the shop. I'd look at the part that I was working, and when I had breaks, I'd go over the assembly line and see how that part was used and what it was done. So I guess at a real young age, I was hooked on manufacturing. I was when I went into that role initially. I was making pretty good money back then. People was right out of high school, getting paid money that other people were putting growing families and putting their kids through college on. And I was this young single person, so I thought I had arrived. But after about 6 months of doing, just factory work and piecework and all that, I got bored and I went into night school and then to a community college and got a degree in manufacturing technology, where I learned about CNC programming and there weren't robotics at the time, but learned a little bit more about machining and metallurgy and everything. So I think that's where the hook was finally set on my interest in manufacturing.
That's great. And did you find when you transitioned from like a vocational school into the job environment that had prepared you at least to get your feet wet?
Absolutely. And probably the biggest thing there was just the culture of people and the work environment there, which, an office is different than a mechanical or factory type environment. And having spent 2 years with those technical hands-on type of people, I started doing things like working on my own car and everything like that. So it steered me in a direction I probably wouldn't want to if I took the traditional high school, college route. Yeah.
See, when I went to school, and I went to a vocational high school, it was very much your first year you had to go through a little bit of everything. You did a little bit of electrical, a little bit of electronics, a little bit of I think we did metal shop, and I'm trying to think of what the fourth one was my first year. But then you had to pick a direction, and then from there you kind of specialized. And I took refrigeration, I took residential wiring, and as well as, of course, electronics and TV and radio repair and things like that. But what it did more than anything was it got me, I guess it set me in a direction of, hey, there's something out there bigger than us, and there's a way that people create, and that people like you and I today, I think it starts to wire your brain in a certain direction. It starts to make you into a problem solver, into a person who questions things and makes you wonder why things are.
Absolutely. I totally agree with you, Dean.
And so when thinking of the 5-year picture of as we look forward to, what are some of the technologies that kind of you get excited about seeing and some of the changes that you see coming down the road?
Well, additive is one of them. In my role at, I moved from the factory floor at International Harvester, became Navistar. And from that, I was involved with starting up in the late 80s, actually mid 80s, the first departments within Navistar focusing on factory floor systems. At the time, previously to that, a lot of the computers were in the office for material systems, accounting, HR, and the dynamic that was happening at the time was the computers were moving to the factory floor from just NC machines to CNC, smart machines, networked, programmable logic PLCs came on board, robots. So I started the first group within Navistar's truck business that put together a team of people to focus on those shop floor systems and integrate them into the office systems. And from that, I moved into creating a similar team within Navistar's engine business. And from that, I was promoted into what's, I think, referred to today as the Chief Information Officer for Navistar's global engine business, which was $700 million in 2 plants when I took on that role. And then 16 years later, we expanded to $3.5 billion in sales and moved globally into South America and Asia. So it was kind of an interesting ride there. So along those lines, my intrigue in manufacturing turned into also intrigue of computers in manufacturing, and that was my new page of excitement there. As far as where I see that going, back in the late 80s, there was a company called SLA, I believe they're still around, and they had invented something called stereolithography. Mm-hmm. And on my team, I had folks that I think a lot of people listening and everything, we all had different talents. And the things that I had on my team, I had some folks that were real forward-thinking type people, but they couldn't really implement anything. And then you had other people that were good implementers that but would be in the same tunnel all the time. And one of my forward thinkers came into me one morning and said, there's this company called 3D Systems, and they've got this thing called additive manufacturing. What do you think? So I teamed him up. We did a little more research on it, teamed him up with some of the Dewar people, and we were one of the earlier on companies to bring in additive in the Navistar, particularly in the engine business. So that was kind of exciting. So looking forward for the 5 years forward, we're not finished seeing what's going on with that, because we've seen additive evolve from a desktop, or not a desktop. The first machines were pretty big. From a toy, looking for a business purpose, to coming up with making patterns, some simple one-time things, and we're really starting to see things about where additive is getting rolled into some traditional machining and high production things. So that's a real exciting area that we're getting into. If some of your listeners are tuned in, I'm very much into technology, so I keep track this week of the Consumer Electronics Show that's going on in Las Vegas. And boy, just check out the publication and see some of the things that are going on in robotics and robots. The change in that just within the last 2 to 3 years is amazing. And stand back and look at that. That's going to have a big impact on manufacturing, also on how we do things. As far as some of the things that are going to drive this, the business need to pull these things in to the U.S. in the next 5 years. We had a big wake-up call with semiconductors, and I was very encouraged to see the CHIPS Act get voted in, and some federal money, because some of these things, in order to pump start it, you need some federal money put in there to turn things around. Mm-hmm. And I think the CHIPS Act is going to put some money on the table, and we can start learning and investing and bringing some of the semiconductor business back to the U.S., which as of today, I think it's only about 12% of some semiconductors that are made in the U.S. And we need that technology was invented here, so we need to bring it back home.
You're right.
Yeah. Pharmaceuticals is another area. A lot of that is offshore, and I think there's a lot of eye-opening things that happened, when we see that 65% of all active pharmaceutical ingredients come from either China or India. And that's kind of a dangerous situation to be in, so I'm hoping we bring some of that on board. Just a lot of really good, exciting things going on. We've got the fundamentals in place, such as the machining, welding, everything like that. Those things aren't going away. They're here, and we're learning different tools and technologies in those areas to make some real dramatic positive changes in manufacturing, even in those very important and traditional manufacturing techniques.
Yeah. And you mentioned robots earlier. Have you seen a lot of changes with how we implement robots? I think in the old days we had very specific ways of how we were going to use them, but now with cobots and even with the business platforms that they're using, meaning that what they're doing now is basically charging you by the hour as if it was an employee. It's changed the way you think about a robot, how you can use it, how much it's going to cost you to get started in it. And even the softwares have changed a lot to where the new softwares are more user-friendly, and you don't have to have a programmer on staff to do things. What
Mhm.
what do you see changing in some of that, and is that something that's got you pretty excited about this?
That's really hard to chart. It's just by the nature of our culture and who we are here in the U.S. And to explain that difference, it was really beneficial for me to get some global experience. Whenever our business at Navistar moved into another country, I'd study the culture and understand the differences, because there are differences between all of our countries. And one of the big eye-opener ones, if you go into a manufacturing plant in Brazil, you'll lay out a process on an assembly line, what to do exactly when. And those workers pretty much, they're going to go by that process sheet, and they're never going to deviate from it, because that's just how they're wired. That's how they're excelled, how they excel and do well. The U.S., we're more kind of like, I guess I'll use the word cowboys, where we think we want to do things differently and everything. And as a result of that, we run into some problems on our assembly lines where folks will be trying something different, 5 stations forward, and all of a sudden 10 stations down the line, people are running into problems because someone got creative and did something out of process. I saw that happen many times. Tying that back into robotics and where that's going to go, the thing that I think is really great about robotics here in the U.S. is we don't know where it's going to go, because we have this culture of thinking, doing things differently, and with most of these technologies, they get thrown out on the table, and I think whoever invents them has no idea where they're really going to go, because once they hit our businesses and our culture and our economy, people take it where you never even think about. So I think that's the big excitement there, is that the capability of the machines and the robots and everything are accelerating exponentially, and where we as a culture take that, I think will put us beyond everyone else in the world just by the nature of our culture.
Mm-hmm.
That difference, I've seen that also in China and in India, So I think you could take the same thing and dump the box on the table and put it in different segments of the world, and I think the folks here in the U.S. are going to take it to places that others won't.
Yeah. You're absolutely right, especially culturally, in countries that I've traveled to, into Asia, into the Middle East, and North and South America. There's differences in everywhere you go, and the way that they approach problems is very different too, and the way that they look at things and how to solve it is very different in different countries and different environments.
And there's pluses and minuses to all of it too, but as far as thinking out of the box, my personal experience have said that we sell at that here in the U.S.
Mm-hmm. I agree. So, talking about like problem solving and workforce, how do we build our worker of tomorrow? How do we find somebody, and how do we convince them that manufacturing is a direction and it is an option for them to look at? Because it's as far as I'm concerned, it's been a pretty darn good environment to work in and learn so much that kind of shaped who I am today.
Yeah, that's going to be a real tough one there too. And then we're swimming upstream on that one from the standpoint of that image of manufacturing that even I brought up early on in this discussion about it being dirty and everything. That was a reality, and there's that image is still in place there. We need to break through that image that isn't manufacturing.
Right.
And it goes back to the parents raising their children. The parents have a tendency to steer their children towards college type jobs versus the hands-on technical type things. I think the thing that can swing that is because we need these highly skilled workers. And I say the foundation for all of this stuff, regardless of robots and technology and additive and everything, the baseline for all of these within our industries are machinists, tool and die, mold makers, foundry workers, maintenance technicians. Those are the things we need to build, because you can't get where you need to go without those type of skills. And as with all things, the first part to solving a problem is recognizing that there's a problem. And I believe that we are definitely there within the U.S. where we're seeing that we have shortages in those areas. To follow up on that, traditionally with businesses that do things, if it makes business sense to build up in those areas, which I think we've been awakened to the fact that we have to grow in those areas, is to put the money in place to attract people into that. And that goes all the way down into, I think, the grade schools and high schools, where we need to start revitalizing some of these programs, some of the STEM type activities, to get the interest in those kids, that as they grow to be adults, that they want to be like I became, and get into manufacturing and learn more and prosper with that. I live in a town about 40 miles west of Chicago, and just before the holidays, I was driving back from a breakfast restaurant and went by our middle school. It was a Saturday morning, and it caught my attention. The parking lot and the streets were just packed with cars, and in fact, a little bit of engineering me, I count everything. There were over 350 cars in this middle school when I was walking. So I guess I found a parking spot 2 blocks away, and I have to see what's going on in here. And I thought it would be a basketball game or some kind of conference or something. But I went in there. It was a national robotics competition that was going there, and they had these middle school kids. I think they go I think this group reaches from 8 years old up to 14 or 15 years old. And this place was just mobbed. And I wish I could put the excitement that I felt in that room with young people competing with these Lego robots across the whole area. When I saw that, I said, this is what you need to put in a bottle and sell. And the most important thing with that is keep those young folks interested in that through high school, through college, or trade school, whatever they decide to go to. Because we're not going to get where we need to go without people. We can say all we want about robots, but robots aren't going to do everything.
Nope.
And behind every robot, there's a team of technical people to keep everything going there. So we really do need to grow in this area, and I'd like to see more programs like that, including through SME. SME is starting to reach down into that age bracket and starting to focus in an area. We realize that that's the future.
Yeah. No, I can tell you a few years back, we had a manufacturing day event, and we had Vex Robotics on site doing a robotics competition at the Science Museum here in Nashville. It was unbelievable, the feeling you get when you see these students passionate about manufacturing and passionate about technology like that. That is something that I wish I could bring every single manufacturer in, or every single person who says, kids today are, they're not interested. I'm telling you right now, if you bring them in, they would have no question to believe that there is an interest. There is a desire to excel in those areas. We just have to find a way to frame the discussion in a way that is appealing.
Right. And then the things like what you saw and what I saw at that age bracket are the things that could to build the momentum. One of the things that I know we've been struggling with in this country is math and science, to get the kids interested in that. Well, part of the reality is you can't equate to them why that's important.
Right. And
when you get them in these hands-on, fun type of activities with engineering skills needed, they can start to understand why they need to learn that math and why they need to learn the science, and how that could get them to do more fun, exciting things in their careers going forward. That is a big deficit or void that we have. And probably the biggest eye-opener for me on that about 5-6 years ago, after I retired, I got involved a little bit with. I became a licensed realtor in the state of Illinois, and it was more for a hobby or anything else because I'm interested in properties and what's going on with that. And just for a challenge, I took a course at my community college on becoming a realtor, and there's some math involved with real estate. Mm-hmm. And my impression, very simple math. It's probably high school or less math that you really need to know to get a real estate license. And the person teaching the class was right around my age, been around for a while. And it was me and another partner that were in the class that were right around my age bracket, and the rest of them were just out of high school or just early on in college, young folks studying to become a realtor. And the instructor in front of the class was just eye-opening for me. He was, when he got to anything to do with math, he talked to the class and says, now, for whatever it's worth, whenever you take your state exam, if there's math involved with it, it's multiple choice, and then you have a 25% chance of guessing it right if you just guess it. And me and my friend looked at each other and says, this guy must be seeing the fear of God in these kids in the class just talking about simple math. And we're looking at this stuff and going, this is like really kind of simple stuff. So that was an eye-opening thing for me. That's the product that's coming out of the high schools now. And we need to nip that in the bud and get that turned around. Hopefully through some of these programs where kids get interested in math and why math is important and everything. So it's not something that they fear that they grasp onto, because that's going to be fundamental. And I don't think you fix that in community colleges or colleges. You need to get at the root source of that very early on.
Right.
To have the younger people better understand why math could be fun.
Yeah. And that goes back to, I can remember when I was in school and there was a lot of people that were like, well, where does this ever apply? And I think that's the key is being able to show people why something is important is far more, and people say, well, I have no interest in going into that, so I don't need to know that. Well, mm-hmm. But if you look at most kids and you see what they're interested in, gaming has a lot of math involved in it. When you're coding and you're doing things even if you're doing it in like Python or other programming, Unreal or any of those types of programming and engines, there's still math involved. You need to understand the general concepts of what you're doing when you're moving somebody across the screen and doing those things. And I think when kids understand that, it becomes more important. And I'd love to see a First Robotics, Vex Robotics type of system competition for other things. How do we take and capitalize that same thing in other areas? So if we're talking about, instead of robots, let's say we're talking about VR and AR. Well, let's have a VR and AR competition to get kids interested in that and get kids interested in other avenues, whether it's math or in science even. How do we figure out a way to make that applied math and applied science something that they can get interested in so that it's not as daunting, not as scary to them, to where they feel, it's easier for me to take the path of least resistance and go and get a business degree.
Yeah. I like your example you used about gaming and the other examples that you gave. And the fact that the thing there might be to trick kids into thinking that math is fun.
It is.
Backdoor. Things, find out what they like and what they're intrigued in, and then let them say, oh, by the way, that you learn math and it helps you better in these areas. So.
Yeah, I mean, if you've ever seen the new, I think it was the Army ads, or maybe it was the Navy, I can't remember, but if you like gaming, and that was it. It was, if you like gaming, you may want to join us. Okay, well. Exactly.
Yeah, that's it. Yeah.
And there's different ways to do things to try and show people that it isn't always about certain aspects. You and I both have a common interest in drones and in drone technology. And you think about how much that has changed today. And I think kids are still enjoying, you got to find those triggers like drones. Oh, kids see it and they like it. They're interested. And then if you get them into a drone competition or into programming and doing different things with drones, it opens up a lot of other doors technology-wise for them and gives them almost that entrepreneurial spirit.
Yeah, the drone in that case is a tool, but in the background, it gives them a path to more technical learning.
Exactly. That's exactly what I was thinking of too. With like how do we develop our workforce of tomorrow? That's one of our biggest challenges. When you think about technology, what other areas, be it VR, AR, or more in the way of other smart technologies, what things do you see being the next growth sector within manufacturing?
Well, I mentioned the semiconductors already. That's foundational.
Mm-hmm.
Seeing a lot of things going on with electronic vehicles and self-driving trucks and everything along the lines of there. So that all requires electric vehicle batteries, which is an issue here in the U.S. If we're going to become self-dependent, we have to develop some domestic sources of rare earth materials, lithium, and everything. Because most of that's coming from Asia.
Mm-hmm. And I think that those areas, you're right. If that's where we're going as a country, not using any other resources, but we're going down the road of electrical vehicles only, then that's really going to put a higher need on those raw materials and a better way to try and, okay, what do we do with when a battery dies? How do we, kind of get that material back out of there and recycle it?
Exactly. And then I'm not sure that whole problem is being looked at yet. We'll probably happen upon some problems that we're good in this country at finding ways to solve things. But just as far as the power grid, power generation, all that stuff, I don't know if anyone's done a macro study on that. But if all of a sudden you flip the switch and we're all driving electric vehicles, are things going to work? So,
yeah.
And a lot of that is being driven, as it should be, for cleaning up the environment. But one of the dynamics that's really kind of cool too in this area of onshoring, there's some studies that have shown the amount of energy that's being wasted by ships crossing the ocean and trucks moving things further than what they need to. So I think as you start doing more nearshoring, onshoring, I think the numbers are it's not going to totally solve the problem, but that's going to be one of the tools in the toolbox for helping clean up the environment too.
Yeah. Yeah, I agree with that it creates a different style or a different way of thinking about, instead of centralized manufacturing, you go in a direction of more regionalized, and that starts to make the argument more for additive. Okay, instead of those huge wind turbine propellers traveling from one end of the country to the other, maybe you print that locally using
exactly.
additive. And I just think that there's some more solutions that we can come up with if we just think about them.
As I said earlier, that we have a culture and a mindset to come up with those solutions. I think it'll be interesting to listen to this discussion we had 3 or 5 years down the road. Boy,
yeah.
What's happened to them, and then we didn't even know. We didn't even have an idea what was going to be coming at us. That's what I think is exciting about all this stuff. That just being able to step back and watch a lot of this happen. First thing you need is capabilities and the tools and the technologies, and then the next thing is a culture and a mindset and an economy that has people take those things where you never thought they could go.
Yeah, and that's the great thing about technology, is that there's more unexpected things that come out of it than the expected ones.
Mm-hmm. Exactly.
So last thought, what other things do you think are changing over the next half a decade, and what technologies should we be interested in?
Well, some of the change, I'll bounce back to the onshoring, because I think that's going to be an impetus for a lot of things that are going on within SME. That we're shifting in some there. We've always been involved with recent years with workforce development with our Tooling U entity, and we're taking that to another level. And we've put an executive in place just to focus on workforce development, and that's a very foundational, important thing for where we need to be going in manufacturing. SME sees that, and we're giving it the focus in the direction, and we want to be a big part, playing a big part in that. The other thing is the business motivation for taking things offshore. I'm seeing some things going on with the government to put some things in place. For example, there's some exposure in military. I'm sure that there's certain parts that we might need for our military that could be made or controlled by an adversary, and all I have to do is shut it off, and we're in trouble. So I think just as recently, Congress passed a bill, and I think it was called the National Critical Capabilities Defense Act, and that's going to require companies to disclose proposed offshoring to foreign adversaries of critical supply chains and capabilities. So excitement there, seeing the government, seeing the business and government waking up to the importance of these things. And as I said earlier, that's the first step. Is the recognition, and from recognition, what are the tools and things that we have in place to do something about it, and then how do we become better than anyone else in the world doing that? And I'm wound up and excited that we're in a good place for all of that.
That's fantastic. Jim, thank you so much for being on the show today. It was great to have you here, and go out and make it a great day.
Thanks much, and for let's come back on in another years to do playback and see what really happened. It's a real good thing.
Sounds great, Jim. Thank you.
Thank you, Dean.